Greetings! So now you are watching the R portion of the non-parametric test assignments that I'm going to be doing. So really quickly, just to go over the test that I'm going to conduct, I am conducting the Wilcoxon rank sums test, and I will also be conducting the Kruskal-Wallis test. Also, this is not real data, this is fake data. For that one person that is more than likely going to take these and run with it, please do not, don't do it. Don't be that person. Nobody likes that person. Be cool, dude. Or chick. Overall, just be cool. Just be cool. So the first thing I'm going to do, I'm going to load up my library with these different packages. So with R, these packages actually allow you to do certain functions. Is that all of them? Nope. There you go. So depending on the package that you upload, you'll be able to do a certain thing. So for example, with ggplot2, you can actually you can plot, or you can create graphs. You can create bar graphs. You can create box plots, whatever you want. So that's just an example. There's more packages, but for the more of those packages are beyond the scope of this video, and I'm only going to load up the packages that you're going to need for these two non-parametric tests. So, you know what, I'm going to label this. So, Wilcoxon rank sums test. So for this specific test, the first thing I'm going to do, I'm going to create my marginalization variable and set it to a factor. So that particular command allows me to do that. I have two levels. There are 10 individuals total. And labels that I'm going to be putting on these levels are microaggression and discrimination. Now the next variable, the next variable is anger, and I'm going to actually input the data here. Well, it's all there. I just have to run it. So I'm going to set that to a factor, and this command actually allows me to create my anger variable. So you want to tie each of these variables into one data frame, and I've done that here with this command. So I've called it anger data, and I use the data frame function to combine or to tie marginalization and anger. And to make sure R has done has executed the commands that we wanted, we can just type in anger data to check it. So I'm going to write down the script really quickly. So this command allows me to check if R has executed, that's funny, has executed the previous commands. Okay, so we're going to do that, and we're going to run it. So here we definitely see that R did what we told it to do. So we see our marginalization variables and the levels. So microaggression, discrimination, and our anger variable. Now really quickly, I know I mentioned earlier that this 10 was the number of participants. No, I was wrong. So this 10 refers to the number of people who had who experienced microaggressions and who experienced discrimination. So they're actually split. The total number of participants are 20, but they're split into groups of 10. Not groups of 10. 2 groups with 10 in them. There we go. So now for exploratory data. So this is like the descriptive stuff. So the first thing that I did, you want to, well, yeah, I did, is get the descriptive statistics. So with this, here we go. With this, you get the mean, the median, confidence interval, standard deviation. But one thing that we're not going to really look at, we're not going to look at mean, because with the Wilcoxon rank sums test, it works on ranked data. So really mean has nothing and can provide us with nothing to what we need to know. I mean, let me not say that. Mean can provide some context, but it's not the main thing that you want to look at here. So here we see for microaggressions 17.5. So really quick, we want to look at the median. So for microaggression, we see that this is 17.5. So that's kind of neato. And then comparing it to discrimination, see 16. So in a sense, you're kind of seeing that they're not too far from one another. They're not too what's the word I want to say? What is the word I want to say? I don't want to say that they're similar or different, because with the median you can't really say that, because I'm so used to saying mean all the time. Now it's like, no, just don't. But yeah, it's interesting to look at. So the next thing that we're going to do, we're going to check our assumptions. We're going to check for our assumption of homogeneity of variance first, and then we're going to check our normality. So for homogeneity of variance, so first thing, homogeneity of variance is, it refers to the variances between the scores in the groups. So with parametric tests, you want them to be similar to one another. You want them to be the same. When you violate that assumption for parametric tests, it's like the end of the world. But with with non-parametric tests, and specifically with Wilcoxon, it's not the end of the world. So, end of the world versus non-end of the world. Which one do you want? So, just to test the assumption of homogeneity of variance, we're going to conduct a Levene's test. So, in this case, in an ideal world, you want it to be significant for a parametric test. Let's see what we have. No! Not really. I mean, okay, so when I run the normality test, you'll see why I said no is not actually bad. But just looking at our test, our Levene's test, we see that we are not significant. So this means the variances, this means that our data, this means we do meet the assumption of homogeneity of variance. So I mean, like, it low-key sucks, but it's not the end of the world. Let's see what the normality test hold, or has. I don't know why I said hold. I'm trying to be fancy. Okay, so this particular command allows me to check for the assumption of normality. Oh my god! So, good news. Well, on one half of it. So for microaggressions, our microaggression data, we actually have violated the assumption of normality. Yay! We know this because it's less than 0.05. So we can assume that the microaggression data or the microaggression condition, the data from the microaggression condition is not normal. It's very much different from the normal distribution. Now, for discrimination, it doesn't want to communicate with, it doesn't want to, comply with us. Like, it sucks. But anyways, we know that it is, we do meet the assumption for normality for this particular condition because we're actually greater than 0.05, so we are not significantly different. So we have met, technically speaking, we have met the assumptions for the non-parametric test. So this is not the end of the world, folks. So we're actually doing pretty good. Now, when it comes to actually doing the Wilcoxon rank sums test, there's a certain way that you have to do it, depending on how the data are stored. So, if you have data that is stored in two different columns, you want to use this particular command. Now, the basic this particular command right here computes a basic Wilcoxon ranks test. Now, you also want to include the continuity correction if your population is less than 40, and if you have ties in your data. The reason being is that it actually throws off it essentially throws off the normal approximation. So the continuity correction essentially tries to rectify that problem. So, like I mentioned before, and looking at our data, just going back really quickly, we do have ties in the data. No, not really. So we do have ties in the data, and that just means we're gonna have to use that particular. We're going to have to use the continuity correction. Pretty much it. There's nothing much to it. So we're gonna run that correction. So now that we have, not correction, that command. So now that we've done that, all we have to do is just run the anger model, and then we get this lovely thing. So really quickly, just looking at it, we see that our p-value is much greater than 0.05. So this means our data is obviously not significant. So breaking it down, what this means is the type of marginalizing act did not differ, didn't significantly impact anger. So the main message with this one is that regardless of the experience that you have with a marginalizing act, it's not going to make you any less angry or any angrier than the other. You're going to be similarly angry, and that's what this tells us right here. So the next thing that we're going to look at is effect sizes. So the effect sizes allow you to see obviously the effect of what your variables have on the on outcome. So with this command, it actually uses a couple of functions to get the effect size. So using the qnorm function, it calculates the value of z. The p-value is stored in an object with the name p-value, so it can refer back to it. The command takes the p-value, divides it by 2, and then it looks at one normal distribution.